warm good afternoon, my dear students. Welcome to this chemistry digital class. Hope so you watched yesterday's video. It was related to the properties of alkene and alkene. Okay, so dear student, if I'll tell you about the chemical properties of hydrocarbon, in which we need to study about the chemical properties of alkane, alkene, and today I'm going to tell you about alkyne and alene. So basically, you know very well about alkane. Alkane is single bonded carbon, alkene is double bonded carbon, and alkyne is triple bonded carbon, arene is a benzene ring. Okay, so if I will tell you about chemical properties are what? These are the properties where we can check that if some other any other functional group or any other compound will react with single bonded carbon atom. This side it is alkane, this side it is alkene. Single bonded carbon atom will react, so what product it will give us? So basically these type of question that can ask in this language, the convert the following. Okay, if question will come, convert the following. Suppose in question if it will come like convert the convert methane into chloromethane. If question will come like this way, convert methane into chloromethane. So very well, student, you should know that this reaction will work because this side it is methane. When it will react with chlorine, so methane will change somewhere into chloromethane by keeping these conditions in our mind. Okay, so this type of question will come in exam, and you must learn this page or this type of question just to solve these kind of question. Okay, and secondly we came to know that okay, the in alkane and alkene, what are the basic chemical properties of these? So today again in the same continuation, in the same part, if I'll say this is part 2 of yesterday's video, that is here we are going to study about the chemical properties of alkyne, that is C triple bond C, and arene, that is a benzene ring. Okay, and you know very well what is benzene ring. It is the 6 carbon ring which have double bond at alternate carbon. So one by one I am going to explain, so please pay attention and watch the video seriously. Okay, the first thing is that properties of alkyne. In properties of alkyne, if we will see the physical property, we did chemical property. The first chemical property is acidic character of alkyne. Okay, one by one I will tell. Acidic character of alkyne, in which first acidic property or acidic character is, it will come when it will reaction with sodium. When it will react with sodium. Okay, what will react with sodium? It means that preparation, reactant side, there should be always alkyne. When alkyne or ethyne will react with any compound or Na, it will convert into Hc triple bond C negative charge Na positive plus half H2. So it is monosodium ethynide, monosodium ethynide. So it is Hc triple bond C negative Na positive, will further react with sodium, will give us Na positive C negative, triple bonded C negative, C Na positive. It is good, it will give us disodium ethynide, disodium ethynide. Okay, so this is the type of reaction, and this is acidic in nature. Clear? Second, addition reaction. In addition reaction, there are following 3 type of reactions we are doing. First is addition of dihydrogen, and already we have studied this. When dihydrogen will react with H2. So in the presence of H2, catalyst Pt, Pd or nickel. Platinum and nickel on heating, the triple bonded carbon will convert into double bonded carbon, and when further it will treat, it will convert into single bonded carbon. Okay, when further it will treat with Pt plus Pd or nickel in the presence of H2, it will convert into CH3. It means that ethane will change into ethene, and ethene will further change into ethane. So in this way we can convert ethyne into ethene or ethene into ethane. Very simple. You need to add dihydrogen with in the presence of these catalysts. Okay. Second is addition of halogen. When CH3 C triple bonded CH will react with any halogen group, it will change into CH3 CBr double bond CH Br, and when again bromination will be there, it will change CH3 CBr CBrHbr. Okay, it will change into 1,1,1,1,2,2 tetrabromo-propane. Okay, it will change into 1,1,2,2 tetrabromo. 1, 2, 3, 4 tetrabromo-propane. So it means that it will change the alkyne into haloalkane. Third is addition of hydrogen halide. Here, when triple bonded carbon will react with HBr, it will change into CH2 double bond CBr, that is bromoethene. Then will further convert into CH3 CHBr2, that is 1,1 dibromoethane. 1 dibromoethane. Okay, or you can say the propyne will change into 2,2-dibromopropane also. Similar way, dear student, the polymerization is the third important property of alkyne. In polymerization, we are basically two type of polymerization: linear polymerization, and second is cyclic polymerization. In linear polymerization, we will get linear chain where CH triple bond CH at high temperature and pressure will change into CH double bond CH double bond CH. Okay, that is long chain of N, that is called N polyacetylene. Okay, similar with cyclic. In cyclic, CH triple bond CH, again CH triple bond CH, or CH triple bond CH. It means that 3 times CH will, when going to be treated with red hot iron, and at 73 Kelvin it will convert into benzene. So this is also important. This is important conversion, and it can be asked in exam also, how to convert alkyne into benzene. So in the presence of red hot iron at this temperature, 3 alkyne will treat with each other. So you can see here, this will go here, double, it will make carbon bond, it will make carbon bond, it will make carbon bond with hydrogen, and these bond will make single bond, and it will form a benzene. Or we can draw it in this way also. Okay, or ring. This is called benzene. Now, before going to move for benzene, dear student, one of the important questions that will come: convert ethanoic acid into benzene. This can come. Convert ethanoic acid into benzene. It means that it will help us to prepare benzene from ethanoic acid, or it is the property of ethanoic acid which convert it into benzene. So with the help of this book, I'm going to tell you this. So this is the very simple question: how we'll convert the ethanoic into benzene. First we will take ethanoic acid. CH3COOH is the formula of ethanoic acid. So first thing that you need to keep in mind, that is hydroxide. When sodium hydroxide base will treat with acid, it will give us sodium acetate. You know very well, when we were preparing soap, so this process is there, sodium acetate. In sodium acetate, when we will add soda lime, so it will convert that CH4 CO2 plus NaOH. Okay, it will remove all whole compound and convert CH3CONa into CH4. Now when we'll get methane, so this is acetic acid into methane, conversion of acetic acid into methane. Now further methane will be treated with chlorine under sunlight. You know very well, it will convert into chloromethane. When chloromethane in the presence of sodium dry, that is Booth's reaction, which we have studied in preparation of ethane from halogen. So haloalkane will convert into ethane. Now ethane will further sunlight in the presence of chloroethane. Chloroethane will when react with KOH. then it will convert into ethene. Ethene is double bonded carbon, still we want benzene, so ethene need to convert into ethyne first. Okay, so how ethene will convert into ethyne, that you have to see. So ethene will change into ethyne when it will react with bromine, so it will give 1,2-dibromoethane. Further KOH will react with dibromoethane, it will change into CH2 CHBr, and in the presence of NaNH2 it will convert into ethyne. That ethyne in the presence of red hot iron tube, just we have done convert into benzene. So like this way ethanoic acid can convert into benzene. Take the screenshot of this page and just practice 2-3 times this question. Okay, now dear student, after this, chemical properties of arene, that is benzene. So first chemical property of arene is electrophilic substitution reaction. It is showing electrophilic substitution reaction. Already we have studied in previous chapter. What is the meaning of electrophilic? Electrophilic is that those compound which attack on the hydrogen on in the carbon compound, which attack on okay, so first is nitration. In nitration, the benzene, a property of benzene we are studying. So benzene we need to make. Benzene will react with HNO3, which is nitric acid, in the presence of H2SO4, concentrated H2SO4. It is also concentrated, will give, add 323 to 333 Kelvin. It will give the, that is NO2, nitrobenzene. Okay, it will give nitrobenzene. So here question can come, convert benzene into nitrobenzene, so that is nitration process. Similar way, sulfonation, again benzene will take, H2SO4 will take in sulfonation, in the presence of concentrated H2SO4. On heating it will change into SO3H, which is called benzene sulfonic acid. Benzene sulfonic acid. Third is halogenation, in which benzene ring will react with halogen group, that is chlorine, and anhydrous aluminum chloride in the presence of catalyst Lewis acid. That will change the benzene into chlorobenzene, and chlorobenzene will give HCl. Okay, so dear student, it is very simple. You can see here in all the cases in electrophilic, one hydrogen replaced from carbon, and that combination of HNO3, SO3 and Cl is there. So it means that it is conversion of benzene to some other compound. That's why it is called property of benzene. Okay, now next is Friedel-Crafts reaction, which is very important, and I am making it under pink box. So pink box meaning you know very well, that is very important for examination point of view. So there is two type of reaction. One is alkylation. In alkylation there is different reaction. In acylation there is different reaction. In case of alkylation, the benzene ring will be treated with CH3Cl, that is methyl chloride, in the presence of anhydrous aluminum. This is hashtag, I can say this is hashtag catalyst of Friedel-Crafts. Okay, ये हमेशा आपको ऐड करना पड़ेगा Friedel-Crafts में. This is Friedel-Crafts catalyst will change the benzene into toluene. Sometimes this question is coming. Convert benzene into toluene, then Friedel-Crafts alkylation. Okay, and if Friedel-Crafts acylation, at that point one difference is there. That difference is, in place of methyl chloride now we are adding acetyl chloride. This is acetyl chloride. Okay, again hashtag anhydrous aluminum chloride, and it will change benzene into, dear student, maximum student I found that they are not able to draw these benzene rings. So practice so that you will prepare this benzene ring properly, and you should know how to draw it. Okay, so now it will give us acetophenone. So sometime this question also coming, convert benzene into acetophenone. So I am going to make the star on all those reactions, which is very important for examination point of view, and it will give CH3COOH acetic acid also. Addition reaction you know very well, where we are adding hydrogen. When hydrogen will add with benzene, suppose I am adding 3 hydrogen in the presence of nickel at 300 degrees Celsius, the benzene will change into cyclohexane. This is very important relation that you need to see. You can see here, dear student, alkyne will change into benzene when red hot iron will add in this. It means that triple bonded carbon will change into benzene when red hot iron will add. Or if I'll say in hydrogenation, when triple bonded carbon will be treated with dihydrogen in the presence of nickel, it will change into double bond. Double bond will change into single bond. Now it means that benzene will somewhere change into cyclohexane when we will treat it with the nickel in the presence of hydrogen. Okay. Similar way, chlorination, it will give us hexachloro, addition of chlorine. Okay, this is addition of chlorine. This is one. Second, I am giving addition of chlorine. When benzene will treat with addition of chlorine, when benzene will treat it with chlorine, like this is benzene, when it will treat with chlorine, 6 molecule of chlorine. So in the presence of anhydrous AlCl3 minus 6 HCl, it will change into 6 chlorine. So you can count 1, 2, 3, 4, 5, 6 chlorine. It means that it is called H hexachlorobenzene. Hexachlorobenzene. Okay. C6H6Cl6 hexachlorobenzene. And it is giving with 3 chlorine. With 3 chlorine it is giving BHC, benzene hexachloroacid. With the help of this picture, I want to just clarify. Addition of chlorine, addition of hydrogen will give us benzene to cyclobenzene. Addition of chlorine is giving us benzene into 2 compound. One is benzene, when 6 chlorine will react, it is 6 to the 12 chlorine. 12 may say 6 chlorine will make HCl and 6 chlorine will attach with the benzene without changing the structure of benzene by replacing 1 hydrogen. Similar way, when 3 chlorine will be there, 3 to the 6 chlorine, so 6 chlorine will attach, but that will remove all the single bonded double bond carbon, so it will change into benzene hexachloride. This is benzene hexachloride, this is hexachlorobenzene. This is difference. Okay, here benzene hexachloride, BHC, which is called, full form of BHC is benzene hexachloride, and this is the structure, and this is hexachlorobenzene. Okay, the difference is only in the number of chlorine. Next is combustion or oxidation, and whenever we are going to oxidized any benzene, when benzene is going to be oxidized, let me make it plus, you take example of any oxygen, any compound of oxygen. Suppose if we will react benzene with oxygen, okay, like let it be 15/2, it has taken in question, then it will convert second carbon dioxide into water. You know very well, this will break down into carbon and water. And one of the important reactions are this: when toluene is the compound of benzene, when it will react with KMnO4 and OH, it will change into benzoic acid. Ethyl benzene will change into benzoic acid, and toluene will change into benzaldehyde. So take screenshot of this, and this conversion also you need to learn, dear students. Okay, so these are all about the chemical properties of benzene. Now after this, tomorrow I'm going to tell you about the conformation and some of the important compounds of benzene. Okay, so till then, take care of yourself, stay home, stay safe, and keep enjoying these digital classes. Thank you. Have a nice